Okay, so the fact of this one is that when you have an oblique cone, the volume of it is exactly the same as if it was a right cone. So if I sketched this and it had the exact same height, like this, right, and the same circumference, you would have the exact same volume. And so you actually don't need to you don't really need to do anything different than if it was a right cone. So what's the formula for a right cone? Well, what we've got is the volume, oops, sorry, the volume is equal to, remember it's a cone, so we have 1/3 the area of the base times the height. Okay, so now what is the area of that particular base? Well, the base is pi r squared because it's a circle times the height. Okay, so let's fill in those numbers. You say 1/2, I'm sorry, or I wrote 1/2, I meant to write 1/3, my mistake, 1/3. So we've then got 1/3 times pi times the radius, which notice this whole thing, the diameter here is 14. We're going to be using half of that just from the center to the edge of the radius. So we've got a radius of 7 squared times the height, which is 27. Okay. Now, just because I'm multiplying in my head, I know that this 27 is a multiple of 3. So if I take 1/3 of it, I just say, what's this divided by 3? And that's 9. So we can write that as 9 times, and I'm going to put the 7 squared here, times pi. 7 squared is 49. So 9 times 49 pi. And I'm just going to show you a little trick down here on the bottom. Okay, just the way that you think about this. Okay, 9, you could say 9 times 49 is just 50 minus 1, right? And if we distributed that through, we could say 9 times 50. Well, 9 times 5 is 45, so 9 times 50 is 450. And then you distribute this through, minus what? Minus 9. So then you get 441. Okay, so we've got then 441 pi, and what are the units? The units, it was inches, so they're inches cubed. And do we see that answer? We do see that answer. We see it there on D. So that's the answer to